Wow, it's pretty wacky in here. When you think of a space war, how do you think about destroying the enemy? Well, if you followed popular culture for any significant amount of time, you're probably imagining some kind of giant space laser coming in to destroy a planet. That would certainly take out an enemy. But I want to suggest to you something more insidious than that. And it's called the Kessler Syndrome, or an ablative cascade. And what that is when there are so many pieces of space junk around a planet that if one of those pieces, it gets to a certain density. Hey, we're live here. It gets to a certain density when there are enough pieces of space junk that if one large one were to explode, it would cascade into the nearest piece of adjacent space junk. And then that one would cascade into the next, and so on and so forth. And what happens is that this creates so many more and tinier pieces of space junk, it's like a runaway chain reaction. And now you have space junk that is orbiting at many kilometers per second around a planet. And it can get to a certain point where there is so much space junk that you would not be able to leave the planet anymore. And based on how we figure we might be able to clean up space junk, the Kessler Syndrome, or the ablative cascade, could last for generations. Because even a fleck of paint going many kilometers per second would go right through you as if you weren't there. So if you were in a space war, what if you targeted a planet's satellites and blew one of them up, or a couple of them up, or inserted your own spacecraft into their orbit and blew it up to initiate an ablative cascade? Then you would effectively lock that enemy on their planet for generations. They would cease to be a problem for you in space engagements. Wow, I sound like I could join the Empire. Hey! Welcome to another edition of Because Science Live, where I try to take your questions and concerns and comments about all the nerdy stuff we get up to on this channel live, off the top of my head. I do my best. And here with me I have Nate, and we are ready to take your questions. Nate, what do we got so far? Better be as nerdy as this, or you're banned.
Alan Fornseth says, how far can Mr. Fantastic stretch out his arm without losing strength equal to if he wasn't stretching at all?
I get a lot of questions about old stretchy boy, Mr. Fantastic. And I haven't looked into it yet. Although, and like a politician, you just redirect. Although, so the strength of muscle is not proportional to the length of that muscle so much as it is proportional to the cross-sectional area of that muscle. So, if you have the same amount of muscle and you were to stretch it out along, let's say, the axis that goes from my face to your face watching this cross-section would necessarily have to get smaller and thinner. Think of like taking a tube and stretching the tube. The tube's cross-section would shrink if you pulled it enough. And because strength in our muscles is proportional to the cross-sectional area, the further that Mr. Fantastic stretched, the less strong his muscles would get, or it'd be harder and harder for him to generate good superhero amounts of strength in his arms. So there would probably be some kind of limit. I just don't know what that limit would be without doing some very complicated assumptions in math. What else we got?
Jeremiah Davidson says, I was watching the original Pokemon series, and in it, Gary mentions that a Diglett can duck underground at the speed of light.
What?
How would this affect its surroundings?
No. They say that? They say a Diglett, they say, no. Someone look it up on the Pokedex. They say that this thing, they say that this dumb looking thing, thing here can, there it is, kind of, that it can burrow or use dig, which is a TM. I think it's TM43, and if I'm right, I win. But it can use that ability to dig at the speed of light, which is 186,000 kilometers per second. If it did that, you'd have to know the mass of a diglet, and it couldn't travel at the speed of light, because objects with mass, if they travel close enough to the speed of light, they start to acquire relativistic mass, and then you need more and more energy the closer that you get to light speed, and then eventually, on this graph here, it goes to an infinite amount of energy that you would need to approach and get to the speed of light. So Diglett couldn't do that, but if he did, and he went from 0 to light speed just in that small distance that he was burrowing, I would imagine that he would undergo, or it would undergo, enough acceleration, let's say a change in velocity, he would rip himself apart. If he can't handle a tackle, he cannot handle going underground at light speed. In fact, nothing can. What's next?
Primark359 says, what superpower do you think is possible with near future technology, and would you want it?
The most possible superpower. I think some version of super strength, even though you don't want comic book style super strength. I think some mid-range version of super strength is going to be pretty doable with something like an exosuit that just acts like muscles on top of your muscles and allows you to lift, say, 200 pounds like it was 20 pounds. Now, you're not doing something like Superman does, where he's lifting, 2,000 tons or more like it's 2 pounds, but it is still augmenting your strength enough that it would be superhuman strength. I think that would be the closest thing in the near future, aside from, let's say, we advanced far enough to get brain-machine interfaces put into our heads that would speed up our thought and our perception. That would be a superpower in and of itself, I think. But those are pretty close, I think. Maybe. It's hard to predict the future. It's always 5 years out. And 5 years later, it's going to be 5 years out. Nate, what do we got next?
Opschlitz says, what would happen when the ISS is decommissioned and falls to the Earth?
So, cool thing, I mentioned this in what episode? In an episode about The Last Jedi. I talked about what would happen if the ISS just fell. So the ISS is orbiting around the planet. And the only reason why the astronauts inside of the ISS are weightless is because they are falling at the surface of the Earth, but missing. They're constantly missing the surface and going around, missing, around. Now, if you stopped this tangential velocity, if you just stopped them dead here, the ISS isn't that high, a couple hundred kilometers above the surface of the Earth. There, they experience still somewhere in the region of 90% of 1g. So they still experience quite a bit of gravity. So if you stop this tangential velocity, they would feel the tug of gravity again, and they would free fall. All the astronauts in the International Space Station would free fall from the distance it's orbiting at all the way straight down to Earth, almost like dropping a stone here on Earth. And they would enter the atmosphere and burn up in the atmosphere. Next question. I mean, it wouldn't be good for them.
D11 Eat. Could the Human Torch produce enough thermal energy to power all the Earth's energy needs?
It depends on how much energy that Johnny Storm? What's his name?
Yeah, Johnny Storm.
Hey, Johnny Storm is putting out. If he's putting out thermal energy, redirect. if he's putting out thermal energy, that means he is probably generating a chemical reaction to produce said combustion of his hot bod. You get it. But the energy density of chemical reactions are nowhere near what he could be producing if he was producing like nuclear fire or antimatter fire or something like that. My point is that chemical energy production isn't as efficient as something like nuclear energy production or antimatter energy production. So if he's just doing it with fire, just one person, I think he would have to be producing the kinds of energies that would just kill everyone and everything around him, and he'd have to be doing it for, hundreds of years to just produce the terawatts worth of power that we would need. It'd be a horribly inefficient power generator. You know who wouldn't be? Dr. Manhattan. He could just induce nuclear fusion to happen by controlling, oh, look at us coming up with interesting things. So in the sun, which you might as well be walking on, it's at about, don't shake your head at me, it's at about 15 million degrees. I know that's not technically scientific notation because just bear with me here. Degrees Celsius. Now that's not enough to induce nuclear fusion in the sun's core, and yet it happens. The only reason why nuclear fusion proceeds is because there's enough particles close enough together that their quantum waveforms overlap and they're able to quantum tunnel into each other, overcoming energy barriers and sustaining a nuclear fusion reaction. So, Dr. Manhattan, with control over the quantum world, could just take any atoms, theoretically, and induce and change their wave function such that he would induce quantum tunneling and induce nuclear fusion. And with everything as potential nuclear fuel, he could power just about anything forever, for our purposes. What's next?
Batman says, how close to
the
sun...
Batman?
Let's
see. Okay, yeah, let's see what the Batman has to say.
How close to the sun can humans go?
For a Batman, he's awfully concerned about the daytime. Whatever. I thought you were darkness and the night. Maybe he wants to become part of the. You know what? How close can humans get to the sun? It's kind of a weird question because on the surface of the Earth, it reliably gets too hot for us to kind of exist on it. You go to Death Valley in California, where I live, not in Death Valley, but California, and it will get too hot at some point for you to sustain the chemical reaction that is your life. So how close can you get to the sun? I'm going to be technical, which is the best kind of fun. How close can you get to the sun? Right there. Wherever the atmosphere stops. Technically. I know that's not the answer you wanted, but I don't care. What's next?
Loyal Opposition says, can a bionic arm really give you augmented strength, aka Bucky?
I think I know what this comment is getting at, and it's funny. So, if you had a metal arm, like the Winter Soldier, sure, the arm might have artificial muscles, but that force has to go somewhere. And if your arm is artificially strong, but your shoulder isn't, wouldn't trying to stop a motorcycle that was going past you with just your arm, wouldn't the arm still rip off because your shoulder isn't strong enough? What Bucky would need is, and I'm sure they thought of this, but what Bucky would need would be to have his bionic arm completely wired into the rest of his skeleton. And even then, there would be a limit because bones have a breaking strength, right? So if it was completely wired into his skeleton and he had some kind of support system where that arm is connected, then yes, the arm itself could probably give some enhanced strength, but there would be a limit because the rest of his body isn't made out of metal. If I try to grab a moving train with a metal arm, my metal arm might not fail, but this might fail, and that would be bad. Same goes for Thor and his hammer. He has to be superhumanly reliably durable, or else grabbing a hammer that's heavy enough and fast enough to give him the momentum to fly away from fire beasts like in Thor Ragnarok, that would rip his arm right off. Probably. So durability is what Bucky needs, which isn't just in the metal arm, I think. What's next?
Kai Hawkeye says, question, could the Hulk pound the ground hard enough to knock the Earth or any other planet out of orbit?
What? Okay, weird question. But what I'm gonna say is yes, with an asterisk. So depending on what canon you want to go with for the Hulk, he can become infinitely strong because he can get infinitely mad, and his madness is proportional to his strength. So if he can get infinitely strong, let's just assume that he can hit the Earth as hard as he wants. Okay, what happens if the Hulk hits the Earth hard enough to give it enough momentum to get out of its orbit, like the escape velocity of the sun? Let's just say he can do that. I don't know what that is off the top of my head, because you'd have to do velocity and mass and all these things, which I think it's 6 times 10 to the 24 kilograms, but I don't know the orbital velocity around the sun. I think it's like whatever. So skipping that for a second, if the Hulk did hit the Earth hard enough for the orbit of the Earth to change, it would also necessarily, because of Newton's third law of equal and opposite reactions, then it would necessarily be enough force to launch the Hulk into space. If the Hulk applies enough force to launch the Earth down, he gets the same force applied to his billions and billions of times less massive mass, and that would accelerate him right out of the solar system. Maybe. But it wouldn't be good for him. You wouldn't want to do it unless you can breathe in space. Then try it. It gives a whole new meaning to the term Planet Hulk, I think. He'd become his own planet, just floating around. Why did I do that? What's next?
From Darko Themsby, question, how would you create a plasma cannon like Gypsy Danger has in Pacific Rim?
There's a problem with plasma. There's a problem with plasma weapons, like in the Pacific Rim franchise or in the Star Wars franchise or Star Trek or whatever. And the problem is that it's a different form of matter, but plasma is kind of like a very, very, very hot gas. It's a gas that is so hot that electrons have been ripped from their atoms, and they're just kind of swimming around in this atomic soup of nuclei and electrons, and that's why plasma can conduct electricity and be warped by magnetic fields, and so on and so on. But what does a hot gas want to do? Well, have you ever cooked pasta or something like that? Have you ever brought a pot of water to a boil? You know that gas, that hot gas, wants to expand and fill the volume that it's in. It has a lot of energy because it's very hot, so you want to fill the volume. So what do you think would happen if you had a gas that was even hotter than steam and you shot it out of a weapon, like a rifle or something like that? It'll go like this. Coming out of a gun, like a blaster or a cannon or something like that, a glob of plasma would immediately and expand and try to fill the volume. It'd be like trying to throw steam at someone. Now, if you're right close to them, it might work. That might be close enough. But if they're at any significant distance, that steam and be completely ineffective. What you would need is either very, 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 very dense plasma or some kind of containment field that follows the projectile, which we have no idea how we would work out. So plasma weapons on the whole are kind of hard to make work plausibly, unless it was some kind of, it was more like a jet. Like a flamethrower of plasma. Then, in short ranges, it'd be like turning a spaceship engine on someone. That would work. But projectiles and plasma, not so much. What's next?
John EG4 says, would you create a vacuum every time you teleported?
Yeah. You're exactly right. Was that John?
John, J-O-N.
Good one, John. Yes, you're exactly right. If I suddenly was gone, if it was instantaneous, there would be a vacuum left here because I am no longer filling this space, and the air would rush in to fill that space at many hundreds of meters per second, I think. And when that happened, you would have an audible sonic boom. It would go bang as the air collapsed in and filled the volume that I was in. So yes, you're right. That would be bad and not very stealthy for a teleporter. However, X-Men thought of this. Again, I never know if people are just accidentally right about things that are happening. But the most famous teleporter in X-Men, Nightcrawler, they say when he teleports, he actually goes through a hell-like dimension that is filled with sulfurous gas and other stuff, and brimstone. So when he teleports, he leaves behind a puff of smoke that is sulfurous and brimstone-y. It would kind of smell like... So if he is leaving behind gas to fill the volume that he is teleporting through, then his teleports would be silent. But unless you have something like that, if you're just in and out, yes, it would be not stealthy, create a very loud sound, and be bad. What's next?
Dafius says, if you ran at light speed around the Earth and jumped...
People love light speed.
Would you fly away, and if so, would you reach escape velocity?
Yes. What? That's it. No, I mean, because there's so many caveats, right? So you can't run at light speed, as far as we know, with modern physics, because it would take infinite amount of energy to get at the speed of light, because your mass would increase the closer you got. That's why we have relativistic equations that deal with stuff like that. So, let's say, can you get to 99% the speed of light? Well before that, you would be to constantly accelerate yourself with footsteps. Well before you got to 99% the speed of light, there would be some footstep that you would go, all right, a little bit faster now, next stride, foot down, applying so much force down on the planet, which would push up on you equally, just like the Hulk, that you would shoot off into space. Think about it. How hard does the space shuttle need to press on the surface of the Earth? Or how much does it need to force mass downwards to get an upward thrust? It's not going the speed of light. It is not producing that kind of force that you would need to get up to the speed of light. So, yes, you would fly up into space. Something that I should have covered in an episode that may or may not be airing relatively soon. What's next?
Character Stigma says, could the hypergate from Lost in Space actually work? If so, could you send the other hypergate using the first one?
You talking about the movie with Matt LeBlanc? No. Next. No, I'm just kidding. But it's been years since I've seen that movie, so I'm gonna have to defer to I don't know. What's next?
Godzilla Wolf 1. Kyle.
Oh, you commented. You're in an upcoming vlog, buddy.
Kyle, would you want super durability in real life, or does it have a similar drawbacks to super strength?
I haven't thought about what the drawbacks to super durability would be. Depends on how it expresses itself. It kind of makes me think of a real-world genetic condition where people cannot feel pain. I mean, I know it's not super durability. Stuff is still happening to these people, but it's a kind of durability, right? It's a mental durability where you can get cut or shot or stabbed or what have you, and you won't feel it. So you could keep going, so to speak. But these people actually live very unfortunate lives because they cannot feel pain. They have the kinds of experiences over and over again that you're supposed to learn from as an organism. So I remember a story, forget where I heard it, about a little girl who touched the tailpipe on a motorcycle and didn't feel anything. They just kept her hand there. No, and just horribly burned and horribly scarred for the rest of her life on her hand because she didn't have that sensory input that would tell her no, shouldn't touch hot stuff. So I have to think about it a little bit, but I'm sure there's drawbacks to everything that changes how we interact with the world because we have evolved to interact very well with our environment. Otherwise, we wouldn't be here in the way that we are now. You change anything about our physiology, there's going to be advantages and disadvantages. Durability has to have some, probably. I mean, you saw some in the first season of Jessica Jones when Luke Cage gets knocked out by a shotgun blast to the face, and they can't administer any drugs or anything like that intravenously. There's one drawback right there. If you need medical attention that requires invasive surgery or something like that, you're done. If you're just durable, but you need to, Luke, you have gangrene. Your leg is gonna rot off, and you're gonna get sepsis. Well, you can't get through my skin. Well, good luck. So, yeah, I think we just wrote that episode together. Nice. Wait, one more question?
We'll wrap it up.
No, just give me one more question.
Okay. All right.
Doing that for you.
Sean Legume says, would spaceships be able to expel excess heat through lasers?
The lasers would actually generate more heat. Just the electricity that you need to pump into a laser necessarily creates more heat on the ship than it does expelling that heat because those lasers, you have to produce more electricity on the ship than is the energy that's leaving the ship. Okay, I'm told. Okay, we should wrap it up before we get more too far into Space War stuff. Thank you so much for joining me for this episode of Because Science Live. If you want more of this, go back to the channel or the Facebook page at facebook.com/becausescience, youtube.com/becausescience, and at becausescience on Instagram and Twitter. And next week, new vlog, new episode, new live stream. And if you are in the LA area, Los Angeles area, tomorrow, and you want to go to the LA March for Science at Pershing Square tomorrow in the mid-morning and the afternoon, I'll be there emceeing the expo. Come and say hi, and we'll high five. Actually, fist bump. It's more hygienic. Have a great weekend, and be nice to each other, because this is all we got.